Now, as I said before, there would be a lot of fraction stuff going on. Okay, so I'm going to write down 2 questions. Let's start with this one. Now, be very honest to yourself. Okay, look at this. Do you want to throw up? Do you want to throw up? Or do you feel disgusted by this answer? Does it hurt your eyes? Okay. How many of you feel like, ooh, that looks ugly? How many of you feel that way? All right. What makes you feel that way? Change the denominator. Okay. Now, do not be surprised that some people will put this as the answer. Okay. Now, why do we need to change the denominator? Is that when we are adding fractions together, we have to have the same basis. Okay. I think back in the days, in middle school, maybe, you use pizzas as a way to think about the fractions. So if you have 2 different sizes of the 2 ways of cutting a pizza, so you have to come up with a standard way of telling what is going on. Now, so you're going to multiply the first fraction by 4 for both numerator and denominator. And then you multiply by 5 for the numerator and denominator. And that means you have 23 over 20. Okay. Now, that's how to do it. But how do you recognize the need of doing it of some people? If you're careless, you may not realize it, but is there a way that you would remind yourself not to write this? Now, this is where I come in and say, well, you know what? Let's think about this. Let's consider this as a pie chart. This is 2/5, right? And this is 3/4. Visually, would you say that there will be more than 1 circle if you add them together? Yeah? Visually. And if you look at this incorrect answer, 5 over 9, I hope that you can visualize that that is not more than 1. It's less than 1. And you can conceptually understand that, ooh, 5/9, totally wrong. Because there's no way that you have something that's more than 3/4, that's the one on the left, and something that is more, 1/4, that's the one on the left, and add something that's 3/4 to have to add up to something that's less than 1. That is just unreasonable. Okay. Now, let me give you something more. All right, are you ready? Are you ready? So 5 over 12, and then we have 6 over 20. Okay. All right. How many of you would do this? Anybody? Yeah? How many of you will write this? If you are doing it, how many of you would actually write this answer? Is it wrong or is it right? Don't think about this as a trick question. I'm just presenting the answer to you, and you assess. What do you think? Is it right or is it wrong? It's right. Okay. When you have fractions, you just multiply across. You don't need a common denominator. However, while this is the right answer, I would say this is not the smartest way to compute, to carry this calculation. And this is my concern with many students, that when you are doing fraction multiplication, you are not thinking about simplification or reducing the numbers first. You should always reduce the numbers before you actually carry out the calculation. The reason is you do not want to make the number so big, then bring it down. Okay, it's more like a damage control. You want to keep the numbers small so that it's easy for you to handle. If you keep the numbers too big, that might create difficulty when you try to simplify it afterwards. So, I mean, you still get the same answer, which is 3/4. Okay, you still get the same answer, which is 3/4, but it will be a lot easier that you recognize that you can reduce the fractions at the very early stage, then you compute. Okay, I'm going to remind you, but I want you to absorb this at this moment. Understand some very common work with fractions, that when we add fractions together, add and subtract fractions together, we're going to have this add and subtract fractions. You have to have a common denominator. When you multiply fractions together, make sure you reduce first. Keep that in mind. Okay.